You are a rounding error. In the first microsecond of existence, the universe created equal parts matter and antimatter, and they should have erased each other completely. Every particle meeting its opposite, every bit of mass converting to pure light. The math says the cosmos should be nothing but an endless, empty glow. No galaxies, no stars, no planets, no you. And yet here you are, watching this video made of atoms that statistically shouldn't exist. So what broke? What tiny imperfection in the laws of physics saved everything from nothing? Think of matter and antimatter like two identical twins born at the exact same moment. For every electron and anti-electron, for every quark and antiquark, they're perfect mirrors. And when they touch, they don't just collide, they annihilate. Both particles vanish completely, releasing their mass as energy. This is real. We see it happen in particle accelerators every day. Now scale this up to the Big Bang. The early universe was a screaming hot soup of particles and antiparticles, all slamming into each other constantly. The temperature was so extreme that new pairs kept forming, but as the universe expanded and cooled, the creation stopped. Only the annihilation continued. Every model we have predicted the same outcome, complete mutual destruction, a universe of light and nothing else. Forever. That should have been it. The cosmic story should have ended before it began. But here's where it gets strange. When physicists calculated how much matter should have survived, the answer was zero. Not approximately zero, exactly zero. And yet we have a universe full of galaxies, each containing hundreds of billions of stars. Something was wrong with the symmetry. Here's what saved everything. The universe cheats. For every billion antimatter particles created in the Big Bang, there were 1,000,000,001 matter particles. That's it. A difference of 1 in a billion. Imagine a cosmic lottery where a billion tickets lose and exactly one wins. That single extra particle, that rounding error, is why anything exists at all. We call this CP violation. It's a tiny asymmetry in how certain particles behave. When matter and antimatter decay, they don't always follow the exact same rules. The difference is almost immeasurably small, but almost did all the work. Here's the number that should haunt you: 10 billion. For every 10 billion particle-antiparticle pairs that annihilated, one lonely matter particle was left standing. Wait, but this creates another problem. We've measured CP violation in our labs, and the asymmetry we observe isn't big enough. Not even close. The imbalance we can detect explains maybe 1% of the matter that exists, which leads to the part that most people never hear about. 99% of your existence is still unexplained. This isn't just a puzzle for particle physicists. This is the central mystery of why reality has structure at all. Every atom in your body, every star you've ever seen, every planet that might harbor life, all of it traces back to an asymmetry we can't fully account for. There are theories. Some physicists believe heavy particles called neutrinos might have tipped the scales. Others think exotic processes in the first trillionth of a second created the imbalance before anything we understand began. But here's what makes this profound. The universe exists on a knife's edge. If the asymmetry had been slightly smaller, not enough matter survives. If it had been larger, the early universe would have evolved differently, possibly preventing the formation of atoms entirely. We're not just lucky that matter won. We're lucky it won by precisely the right margin. Think about that. Across 13.8 billion years, across 2 trillion galaxies, across 100 billion trillion stars, all of it balanced on a 1 in a billion fluke we still can't fully explain. So the real question is, does this change what we think is possible? Right now, teams at CERN are hunting for the missing asymmetry. The Large Hadron Collider isn't just smashing particles for fun. They're recreating conditions from the first moments of existence, searching for new forms of CP violation we haven't detected yet. In Japan, the T2K experiment fires neutrinos through 400 kilometers of Earth, trying to catch them behaving differently than their antiparticle twins. And at Fermilab, researchers are measuring the magnetic properties of muons with insane precision, looking for hints of physics beyond our current models. This isn't abstract. These experiments have deadlines, grant cycles, graduate students who have bet their careers on finding something. Every few months, new data drops. Each analysis could reveal the mechanism that saved the universe, or it could deepen the mystery. The people working on this problem check their instruments at 2 in the morning, knowing they might be the first humans to explain why anything exists. So look at your hand. Those atoms, the carbon, oxygen, hydrogen, they're survivors of the greatest annihilation event possible. 1 in a billion. A rounding error in the math of creation that somehow added up to you. The universe didn't have to exist. It almost didn't. And we still don't fully know why it does. Every galaxy you see is evidence of an asymmetry we can't explain. Here's my question for you. What do you think we're missing? New particles we haven't discovered, or entirely new physics we can't imagine yet? Tell me in the comments. Follow for more. We post every week.